Welcome to Study Loop.
This is the answer to Chapter 21, problem number 87 from the Smith Organic Chemistry textbook. This problem talks about beta-D-glucose, a hemiacetal, can be converted to a mixture of acetals on treatment with methanol in the presence of acid. And we're asked to draw a stepwise mechanism for this reaction and explain why two acetals are formed from a single starting material. Okay, and so the stepwise mechanism is going to go like this. So the first step is going to be protonation of this alcohol. So it's going to grab a proton from the acid and okay, and so once it's protonated, it will look like this. And so we know it will have only one lone pair and a positive charge. And it's going to be a good leaving group now. It's going to be able to leave as water. And so that is what's going to happen. The carbon-oxygen bond there breaks. And that is going to take us to this intermediate. That is a terrible looking thing. Let me try to draw it again. Somewhat better. So that's going to take us to this intermediate where we have a carbocation. And I suppose I probably could have fit this all on this one page, but I didn't think that I was going to. So we have our carbocation here now at the bottom carbon of this ring. And so remember, carbocations are trigonal planar. And as a consequence of that, and let's look at the next page, as a consequence of that, the methanol is going to be able to attack from either direction. So it can come from above or below the plane of this ring, since it's going to be a trigonal planar flat carbocation. And so when the methanol comes from above, we get this structure. And again, I'm not drawing this well. It's a little better. So when the methanol comes from above, it adds like this. And so we have a positive charge and one lone pair. And the next step, the final step, is going to be that the chloride ion that we formed in the first step is going to come along and deprotonate. And so now we formed one of our product acetals. Okay, so that's our one product, acetal. But the methanol can also come from below, since it is a flat trigonal planar species. And so, really struggling to draw the ring in this orientation. So if the methanol instead comes from below, our product will be this one. So the axial addition product rather than the equatorial. And so, you know what? Let me move this whole thing up. A little better. Again, it'll be the axial addition product rather than the equatorial. And what can happen now is the exact same thing. So we'll have a positive charge and one lone pair on this oxygen. And again, the chloride ion is going to come along and deprotonate. And so the result of that is going to be the same molecule, but with the opposite orientation at this acetal. Okay, and so now this looks like this. And again, we get that mixture of acetals because we proceed through this carbocation intermediate, the first structure that I've drawn on this page. And because it's a flat trigonal planar intermediate, the methanol can attack either from above, which is the top pathway, or from below, which is the bottom pathway. And that explains our mixture of acetals. And so this is the end of the mechanism. Here, page 1 is the first 2 steps of the mechanism. And that's the answer to chapter 21, problem number 87.